Hey guys, welcome back to another RASK Maths video. And in this video I'm going to be showing you guys how to solve this SMC 2022 question 19. So, like most SMC questions, there's multiple ways of doing it. And first I'm going to show you the purely algebraic way. Then I'll show you the much simpler but also less rigorous way. So let's do this with algebra first. The question wants us to figure out how many solutions there are to these simultaneous equations. So not even what the specific solutions are, but how many there are. So with algebra, we can just set up a simultaneous system of equations. Notice how this isn't a linear system, so it's going to be difficult to reduce variables by eliminating. But if we instead just subtract the whole thing, and see how there's two squares, that should be a clue that we can use difference of two squares. So let's subtract everything and we'll get 0 on the left side, which is good because it means we can factorize out and set things equal to 0. So using difference of two squares here and swapping the x and y around, we get this, which then leads to x minus y. And then factoring that out, we get these equations, and from here we can just set each of these equal to 0, since a product equal to 0 must mean either one of these is equal to 0. So either x minus y equals 0 or x plus y plus 1 equals 0, which leads us to x equals y or x equals y minus 1, minus y minus 1. Now, this doesn't actually mean all points along this line are going to solve these simultaneous equations. But you'll see if we plug x equals y into this, we'll get a quadratic in y. Similarly, if we put it into this, we'll get a different quadratic in y. We'd get the same quadratic in y since it's kind of symmetrical. But yeah, so we can plug it into either equation. And let's do that first. So if we put this into equation number 1, we get x squared minus x. Then I'll move the 2022 to the other side, and that's equal to 0. Now, there might be a nice solution for this, but it doesn't actually matter. We can just look at the discriminant. So that's going to be 1 plus 4 times 2022, and that is greater than 0. So we can conclude there's two solutions for this equation. And then we'll do a similar thing, but for this instead. I'll substitute it into this one so we don't have to square everything out. So we're going to get y squared plus y plus 1 equals 2022. Y squared plus y minus 2021 is equal to 0. And this is actually good because if this was a minus and a 2022 there, that would be the same equation. So we'd end up with the same roots. So even if we have two solutions, they'd just be the same as the ones here. So we'd have to ignore them. Luckily, it's not the same equation, so it's probably not going to have the same roots. We can work out the discriminant again, and this is also clearly greater than 0. So therefore, we have another two solutions over there, which altogether gives us 4 solutions, giving us the answer E. Okay, so that was one way, the algebra way. It wasn't actually that long, but there's an easier way. So again, let's look at our simultaneous equations. We have x squared minus y equals 2022 and y squared minus x equals 2022. So what you'll notice is to get from here to here, we're just mapping xy to yx, right? Because we replace all the x's with y's and all the y's with x's. So this is the mapping, and this mapping is equivalent to a reflection in the line y equals x, which makes sense if you think about it, because when you're reflecting a line y equals x, you're just swapping the x and y coordinates. So that's how you end up with this. And so what we can do is, if we take the first equation, it's a familiar sort of quadratic equation. We can just plot it on a nice graph over here. It's going to look something like that, going through minus 2022. And let's just draw the line y equals x on here. So equation number 2 is just going to be a reflection of this, but in this line. And you could also rewrite it as x equals y squared minus 2022, which means it's going to look something like this. So this point here is actually root 2022, which means our x-intercept is going to be much further back. And it's going to be something like that. And again, we know that intercept is root 2022, which is how we know it goes here and not underneath like that. But yeah, once we've got these graphs down, it's pretty easy to see that the solutions are going to lie wherever there's an intersection of these graphs. So we have 1, 2, 3, 4 solutions. Okay, thanks for watching, and I'll see you guys in a future tutorial. Bye.